now have 5 more illustrious Manhattan Project veterans to talk to you. Just, again, a little soup song, a little flash of their memories, whatever they want to contribute to this tapestry of memories. So the first person we have is Isabella Carl, who worked at the Met Lab as a young bride, only 22 years old. She came, really got the job sight unseen. Maybe, Isabella, you want to talk about some of your experiences there.
Thank you. At the time that I was asked to come to Chicago, I knew nothing about any projects around the country. I knew nothing about plutonium. Of course, I knew very little about plutonium even after I went to Chicago. My husband and I were getting our graduate degrees at the University of Michigan. And in that summer, he got a notice from his draft board that as soon as he finishes his PhD work, he was going to be put into classification 1A. And I think most of you know what that meant. And that didn't please him very much. On the other hand, he was quite surprised and delighted when he got a letter out of the blue inviting him to come to work at a project in Chicago whose subject matter was not to be discussed. It wasn't discussed in the letter either. And so he immediately accepted that position. I still had several months to go before I got my PhD, which came the following December. All the time he had been working at Chicago, he did not tell me what he was working on. He was not supposed to have, and he didn't. And I had no clue whatsoever what the experiments were like, except that he said I would find them fascinating. So when I got my degree at the end of 1943, I think it was 1943, I moved to Chicago with him and appeared at the laboratory one day, and they were all ready to receive me, even though they never asked me to come. And I was assigned to a small group of people, one of whom I knew. I knew Norman Davidson, who at that time was already a PhD and a postdoc in England as well as the University of Michigan, and he and I shared a double desk for about 2 weeks. And apparently he was one of the people who suggested I come to work with him. We were a group of 5 people, and our mission was to take plutonium oxide, which came from Oak Ridge. Now, I do not mean to be disrespectful in any way, but the plutonium oxide from Oak Ridge was sort of crummy, chemically speaking. I mean, it was a great source of material, but it was our job to make pure plutonium compounds, particularly the halides in our small group that were really chemically pure. I understand why I was asked to work in this group, because the procedures, the chemical procedures we used, were were on a vacuum line. Vacuum lines were chemical structures that were built to carry out chemistry in glass tubes that were pumped free of air or other gaseous contaminants. And I had done some of that in my graduate work. I knew how to blow glass, I knew how to make a vacuum line, I knew how to measure vacuums, and that put me in good stead for the experiments I was to prepare. However, what I didn't expect was that the temperatures I had to work with were near 1,000 degrees centigrade. That's pretty hot. And I couldn't use Pyrex glass because that would melt much too soon. So I had to make vacuum lines from silica. And silica was obtained commercially in tubes. So I was given a number of 6-foot length tubes that I would use my glass blowing techniques on to make the apparatus necessary for making the plutonium chloride. I was the one who was to make the chloride, which was fine with me. But I had to do what used to be glass blowing on Pyrex. Instead of using Pyrex, I had to use the silica tubes. And that wouldn't melt in an ordinary torch. I had to use hydrogen and burn hydrogen at as I mentioned, close to 1,000 degrees. I never did know what the temperature was, but I did manage to put a apparatus together, and I did manage, indeed, to start out with the plutonium oxide that had come from Oak Ridge and react it with any number of organic chlorides. And indeed, I was able to make plutonium chloride in about 6 different ways at these high temperatures and transfer them under vacuum to little tubes and take them over to the physics building at the University of Chicago, where Professor Zachariasen was an expert in X-ray diffraction. Now, he was an ex officio member of the community working on the plutonium, and it was in his laboratory that he analyzed my crystals to show that, indeed, they were what I said they were. There were several incidences while I was doing this sort of work that I found somewhat amusing, in that I think I was the only female scientist at that time at the University of Chicago working on this project. There were other women, of course, who worked in the offices and did other clerical work, but I was the female. I had pigtails still, and I must have looked as if I were a somewhat young college student walking around campus when I was carrying around crystals of plutonium chloride in my pocket. And this went on for quite a number of weeks until security found out about it. Oh no, I couldn't do that. Well, how was I going to get my crystals from one building to another? It was about a city block's walk from New Chemistry over to the physics building. And after that, 2 guards, dressed as guards, were walking down on either side of me when I transferred my samples from the one building to the other. And I'm sure there were enough eyebrows raised as to why this girl with pigtails would have 2 guards accompanying her. Well, I was quite successful in making the plutonium chloride crystals in about 6 different ways using different organic chlorides. This was simple chemistry, and it was not much different than if I were working with uranium, so that didn't take all that much thought. And that was my contribution to the project of making pure plutonium, because then they had compounds that were 100% plutonium chloride, and they knew what else to do with it in the process of making bombs. The people who were working with me were not all that lucky. Joe Katz, who was my elbow partner, so to speak, in our experimental room, was working on a bromide, and he also was able to grow nice plutonium bromide crystals. And then after bromine comes iodine, and the man who was working on iodides, yes, he made purple crystals. They no doubt had the iodine in them, but he never could quite make a pure compound. There was a mixture of iodides. The iodides and the plutoniums just didn't like to nestle against each other in a molecule, so he had more of a difficulty. I don't know if the iodides were ever used afterwards because of the difficulty of making pure ones. And then there was the problem of the fluorides. Nobody ever told the person who was supposed to make the fluorides that once the fluoride was made, it was volatile. And so what happens to volatile things, unless you catch them properly, they go into the room, they go out through the ceiling, they go into the Chicago atmosphere. So I don't know how much of the fluorides are still stuck somewhere or other around the new chemistry building, as it was called. I guess not many, because that building eventually was torn down after the war. Other experiences were that we always carried a counter with us. They were primitive counters as compared to later ones, but we always carried a counter with us. And as I was walking up the hall right after lunch one day, we never ate lunch in the building. We always went elsewhere to eat lunch. But I was there early, and my counter went off. And it got louder and louder as I approached the Coca-Cola machine. And it really went off right next to the Coca-Cola machine. And so I immediately called people in that we had a problem there. The problem was that when everybody was out to lunch, the man who delivered the syrup, in those days, he had syrup come down one way and ice cubes from another place, and they mixed together in a cup, and after you put your nickel or dime in, you could get the Coca-Cola in a cup. A newfangled machine that the Coca-Cola was proud of. except since it was completely radioactive, it wasn't the thing to drink. Well, it happened one day when we were all out to lunch that the man delivering the Coca-Cola syrup came and left his hose that he used for pouring syrup into the machine back in his truck, and he didn't want to go through security again, so he looked into one of the laboratories, and there were nice tubes all over it. A nice wet laboratory that handled plutonium, and he used it. Fortunately, for a good many people, I had come back from lunch somewhat early, and I did have my counter on, and I did notice that there was a big problem. And after that, we got a different kind of a Coca-Cola machine, one that had bottles in it that were where the Coca-Cola was already bottled elsewhere.
Thank you very much. That was terrific stories.
Thank you.
So working on the Manhattan Project could be adventuresome. Next we have Irene Laviolette, and she has some stories too about her trials and tribulations.
Well, it was in 1943 when I graduated from Barnard College, Columbia, majored in chemistry. And I was very lucky to get a job at DuPont in Niagara Falls in the research laboratory. The DuPont branch there was called electrochemicals. Shortly after I was working there, I met my husband, but not at the plant. We both were attending at the YMCA different interest groups of interest. And the one that I had attended was the International Relations Group at the YWCA, where also my husband was attending. And that's where I met him. Of course, he said he knew about me as a new arrival at DuPont, and he had seen me, but I hadn't seen him before. Shortly after that, I heard that he was asked to participate in the Manhattan Project, and he had to go down for, first I should say, shortly after, he proposed to me, and I had to make a decision whether I would go as far as out west when he told me that he was asked to participate in a new project which needed also training. The reason was my parents were in Athens, Greece, and Greece was still occupied. And I was able in 1941 to be repatriated back to the States after the German occupation and continue my education at Barnard. I already had 2 years at the chemistry school in Athens. So Greece was still occupied, and the only way my parents would know what I was doing was through 25 words of messages through the Red Cross. But I made the decision to go ahead, and we were married in May of 1944, after he had a little training in Delaware. And shortly after, we started for out west. Upon arrival in Richland, Washington, we had to stay at different quarters because housing was not ready, and we had to wait for our one-bedroom prefab. Of course, families had priority, so that's how we spent our honeymoon. My job at, first of all, I got reinstated. DuPont was running Hanford for the government. So I got reinstated, and I was able to work in non-secretive work. My work was more or less control work. I was analyzing the water of the Columbia River. I was helping another physicist with the polarograph analysis. I did some work with the Geiger counters when they had arrived. And that's how my contribution was. My husband's, of course, was in the big secret, and I am not going to cover his work, except I know he worked with the production of plutonium, and he contributed highly in figuring out how to prevent the casing from melting at high temperature. And that was a great contribution by speeding everything up. After our assignment was over, we went back to Niagara Falls to the DuPont branch that we were working before. And Fred stayed there until he decided to go to Schenectady when when GE was planning to go into the atomic energy, and he worked for the Atomic Knowles Laboratory there. And after that, after my return from Richland, I stayed home and I didn't go back to work because I started my family.
Well, that was a good thing to do. Your daughter is sitting right here. Thank you very much.
I don't want to say anything more. That's about it.
Let's see, next on the list, we could just go down the table, I guess. Jim, do you want to speak next? Or Hal? Oh, if we go, okay, alphabetically it is.
I'll talk.
Okay, Hal Levy is our next speaker.
I'm not going to discuss any science. I'm going to tell you when I was in the Corps of Engineers, the combat engineers, and it was a combination of naval people that were interviewing me. I didn't know anything about it. I didn't why the Navy was interested. Apparently, I had taken some examinations and they were interested in getting me out to Chicago. They told me that I was on call, and the next thing I know, my commanding officer hands me a ticket and says, "You're on your way to Chicago to Union Station." They gave me a phone number to call when I got there. It's all mysterious. When I got the phone call, the woman answered. She turned it over to a man who said, "Put a magazine under your left arm and you'll be approached." So I'm in this mysterious thing, and some guy an hour later comes over with, says, "Were you waiting for somebody, Mr. Harris?" My first name is Harris, so I remembered his name. And I said, "Yeah." He says, "Follow me." "How about my bags?" "Don't worry about it." So they took me to an automobile. There was a chauffeur, and drove down the Lakeshore Drive, and they were explaining to me about all the museums and everything that was on the lakeshore. I said, "I'm sure this has a lot to do with my military training." Anyway, they dropped me off at a hotel on the south side and told me to ask for Mr. Midlack, which I did, and I went up to his room. He wasn't there, but his wife was there, and she said that this man is your first sergeant. You're going to be working at the University of Chicago, and you're going to be working on radium. Well, we were never working on radium, but nobody knew that at the time. They asked me where I lived. I told them where I lived. They said, "It's too far. You'll have to ask them to send you civilian clothes because the university would not permit you to go to work without civilian clothes." So several weeks later, I got my civilian clothes and went to work, and I found myself working primarily to follow the scientists so that because my boss, who was a colonel, said to them, "These are foreigners, and you can't trust them. And so you're supposed to watch them and see what they were doing." Well, part of the time I was watching them on the blackboard at the university. And I had all kinds. I thought I was a mathematician. These people were working with complex triple integrals, you know what that is, and I didn't understand what they were working on. So I was one hell of a guy to report what they were doing. But anyway, during that period of time, we were actually built the first nuclear reactor that ever existed in the world. It was in the West Standspile at the University of Chicago, and is now a museum piece out at the Fermi Lab. And as a result of this nuclear reactor, I worked with Enrico Fermi, who I loved. He was a very nice man. And Leo Szilard, who was from Hungary. Fermi was from Italy. And Szilard was very difficult to me. Every time this colonel would ask me to do something for Szilard, I would get a piece of paper out and start to draw things. That he'd draw a line here, draw a line there, make a circle. I said, "Doctor, if you tell me what you want, you'll have a much better job." And he waved his hands. No way he was telling me what those lines meant. So anyway, it was one of the things. I don't want to get involved in the scientific portion that I hope I did with Enrico Fermi and Szilard. I'd rather tell you about my personal experience, which was very great. And one of the things that I could tell you about which I'm interested was at the end of, it was August the 6th, 1945. Arthur Compton, who was in charge of Howard University and all the scientists there, called the academics down to the Great Hall. We who were in the scientific involvement were called academics. Anyway, we get down there and Dr. Compton says, "Gentlemen, you were successful. The bomb was dropped on Hiroshima, and you can go and now call your wives and tell them what you were doing all these years." So I got home, as did almost everybody else, call home and say, "Listen to the radio, no TV. Listen to the radio and you'll find out what I've been doing," which I couldn't tell you about. It wasn't 15 minutes later, Arthur Compton calls us back to the Great Hall and says, "Gentlemen, the university does not want anybody to know they worked on the nuclear bomb. Don't call home." And you know what everybody said? Forget it. There was probably not a soul that didn't call home. Anyway, I thought I would tell you about these things because talking about the science or what I did and so on, right now seems so far from me, I don't even remember. The thing that I do am astounded here is that there are so many people who are my age and maybe older who worked on the project, and that really amazes me because I wouldn't have believed it.
Well, thank you very much. I can see Jim is ready. So Jim Shoki is going to share his experiences from Chicago.
Good afternoon. I'll be talking tomorrow about some of the work, development work I did, but I have a few anecdotes for today. First, I'd like to say how privileged and honored I was to have been selected to be in the Special Engineering Detachment of the Corps of Engineers and assigned to work on the Manhattan Project. It made my life. It really did. And then I'd like to say that I got in, how I got into onto the Manhattan Project to begin with. I was in sophomore year in college at Illinois Institute of Technology, studying chemical engineering. I later changed to physics, but the draft board was breathing down the back of my neck, so I looked around for some program that I might enlist in that I'd be able to continue my education. And fortunately ran into a Signal Corps training program and enlisted in that, and they sent me to school, radio and electronics school, which ended up in a 20-week course at graduate level at the University of Chicago. And as a result of that, at the end of that class, which happened to be the last Signal Corps class at the University of Chicago in that program, some of us at the top of the class were interviewed. And I had two interviews. One, I didn't like the sound of it. They talked about being in intelligence, connected with intelligence in Europe and radio communications. And I don't know, somehow it didn't appeal to me. The other one they didn't talk much about, the other interview, but they said it was an important project for the war. And I was interviewed for it, and then I went to active duty and was the Signal Corps attached to the Air Corps and in basic training camp in Miami Beach. And that was an 8-week basic training. And the 4th week, we're called, every morning we went to the beach for exercises and then marching and so on. And we was called for reveille at 6 o'clock in the morning. So, and I was on a 4th flight in one of those the old disco hotels at South Beach. And of course we didn't use the elevators, we had to use the stairs. But that was all part of it. At any rate, I go down for reveille, and my one-eyed corporal from Georgia, who was angry at the world because he couldn't be overseas fighting, yelled out, "Shoki, you SOB Jew, come forward." So I went forward and saluted, and he says, "Who the F do you know in Congress?" I said, "I don't know anybody in Congress." "Oh, you're kidding me." He says, "The captain's got secret orders for you." Wow, that was news to me. So I go to the captain, and sure enough, he gives me an envelope with secret orders. And after I left him, I opened the orders, and there's a railroad ticket and some money. And instructions to report to an armory in Chicago. So from Florida to Chicago, and then I go to the armory and report there, and of course I'm in uniform. And then they took me over to the Ryerson Physics Building on the University of Chicago campus, where I was introduced to my group, to the section chief, who was from the General Electric Company, a great guy. And this was the instrument section of the metallurgical laboratory at the University of Chicago on the Manhattan Project. And I was assigned to do development work on radiation detection and measurement instruments, which I did. Also, while there, while we were only told what we needed to know, to do our jobs. But being involved in radiation detection and measurement, we had to know something about what we were measuring and where it was coming from. So I was invited, along with many others, to lectures by Enrico Fermi, and some of his assistants, Philip Morris, Dr. Philip Morrison, for example. At any rate, that was part of the wonderful experience that I had on the Manhattan Project. As a result of developing an improved alpha ray measurement instrument, which was widely used at various sites on the project around the country, I was assigned to do liaison to train people on the use and maintenance of the equipment. And so I traveled to all these different sites, and many of which, I made many trips, I don't know, half a dozen or so trips to Los Alamos at various times. And on my first trip, which of course was I was not in uniform for any of this at that time. although I was still in the military. On my first trip to Los Alamos, I boarded the train in Chicago at about 3 o'clock in the afternoon, and it was the Santa Fe Railroad, and I went to sit in the club car to read a book. At about 4 p.m., I heard somebody say, "Mr. Shoki, I'm on a secret project." I look up, and there's a gentleman standing there, and he says, "I'm Dr. Serber, Dr. Oppenheimer's assistant. Dr. Oppenheimer would like you to come to his stateroom for cocktails and conversation." So at around, I don't know, it was 4:30 or something like that, that I was invited to come, and I went. And there were 5 or 6 gentlemen. I was 20 years old. They were all more elderly people standing around the open door of his compartment or stateroom. And he was he came up to me and introduced himself. "Call me Oppie." Wow. They stood there talking and nothing about the work or what we were doing or where we were going or where we come, why we were going or anything. It was all just conversation about the war and other things. Any rate, Oppenheimer liked to recite poetry, and he also quoted philosophy from the Bhagavad Gita, which was a Hindu, I don't know what you call it, not a Bible, but a philosophical book. And he was really a very interesting guy, and I was amazed. I mean, this very erudite man was so humble and willing to have a 20-year-old nobody as his guest. It really was an unforgettable experience.
Thank you very much, Jim. And last but not least, we are very pleased to have Will Lowe here to share his experiences.
I've been admonished to tell the truth, so I'll do that according to my version of it. After having led a group at Los Alamos to develop the device to purify plutonium, I was invited by the newly formed Atomic Energy Commission to go to Hanford and have a look at what was being done there with the equipment which would do the same job. That led to a number of different things, but one of them, I ended up with programmatic responsibility for 3 new reactors and for the new laboratories, and was also asked to oversee what General Electric was doing to design and build what we had done to develop a purification device at Los Alamos. One of the first things that I took on the job of just having an oversight of the reactors to learn about them. And there was a problem. The reactor graphite stacks were growing. They were about 20 by 20 foot cubes of graphite with about 2,000 tubes made of aluminum through them, in which contained the fuel. The neutron flux in the reactor caused the graphite stacks to swell. That could cause some of the safety systems to be compromised. And so a group was gotten together to figure out how to anneal the graphite stacks. And physicists were brought in from the University of Washington in Seattle, one of whom was Paul Gass, and he suggested that we add carbon dioxide to the nitrogen blanket cover of the reactors in order to warm them up, and hopefully the atoms which have jumped out of place and caused the swelling would jump back to where they ought to be. And that was tried, and it worked. The graphite stacks were annealed, and that problem was solved. At the time, however, sitting around one evening after the day's work, somebody said, "What's going to happen to the atmosphere if we keep burning thousands of years of accumulated carbon and putting it in the atmosphere? Isn't the atmosphere going to warm up?" And the answer was obviously yes. That was, and fundamentally we all agreed that was going to happen, but we didn't know what the consequences would be. But this was as early as 1950, and it was rather obvious at that time, in simple terms, that climate change was going to occur. And so some of us began to advocate very soon thereafter that we had to stop burning fossil fuels. And of course, the natural thing for me was to prefer to go to nuclear power plants and electric cars. Other things that happened which were notable there was in building the new reactors, the D, DR, and K reactors, for which I had programmatic responsibilities, things were not going well. And an old hand at building dams in the Southwest named J.R. Thomas came in, and he spent 3 days in the field looking at what was being done. There were 5,000 workmen out there that had to be bused about 40 miles from the town of Richland, Washington, to the Hanford site, which took about an hour, and there were about 50 or more buses. And he decided to shut down the whole site. He shut the whole site down. And then he said, the men can go back to work when their name is on their helmet and their job. They wore a helmet that was colored to specify which kind of a job they had, like welder, pipe fitter, cement worker. And when that's done, they can go back to work. In about 3 days, that was accomplished, and by the General Electric Company, which had the fundamental contract for operation and construction. And Thomas opened the job up and went out and checked on what was happening, and the work efficiency was increased probably about 20% or more, and a lot of the malingering which had been going on was stopped. The other aspect of this was that there was concern about the Columbia River. The reactors at Hanford were raising the average temperature of the river about 1 degree Fahrenheit. And also, sodium dichromate at 1 ppm concentration was in the water that was put into the reactor to cool them, and then subsequently went to the river. And the question arose as to what that was doing to the salmon fishery in particular, but other species which lived in the river. So a fish lab was established, and a young man from University of Washington in Seattle was brought in to run it. And it turned into a very wide-ranging environmental investigation, which in a way was a precursor of what was later required by the Environmental Policy Act. I think those are some of the highlights from the Hanford experience, which started with work at Los Alamos.
Well, thank you all very much. I mean, this has been a wonderful afternoon with a lot of different perspectives on this program, just to give you an idea of how varied the activities were across the country, how the experiences of individuals differed and yet were the same in so many respects. And if you liked this, you can go to our website, Voices of the Manhattan Project. And we either have now or we will soon have full interviews with every one of the speakers you've heard this afternoon, plus another 250, and we're hoping to make that 500 in the next couple of years. So these are all interviews that are completely transcribed and searchable. If you're just interested in stories of Oppenheimer and conversation and cocktails. You can put conversation and cocktails with Oppie and see what comes up. Or if you're interested in plutonium chemistry, you can put that in and search whatever factors you want. But we hope that you enjoyed this afternoon and invite you now to spend some more time with these veterans and with each other over some refreshments. And please come back tomorrow for more.